All right. Wow. A lot of motivated people this morning. Thank you for joining this session on a Friday at 9:30. Some of you may have had a good night, a couple beers. I did too. But I made it, and you did too, so applause to yourself. Or not? Okay. All right, so in this session, we're going to talk more about AI. I'm sure you've not seen enough of AI, but this time we're going to jump into how we can actually leverage AI in our local environment, because we've been talking a lot about all these really cool AI systems, but what I've not seen very much is how I can actually use that on my local machine where I don't have to pay, and where I can just kind of experiment and see how it all works. And so we're going to go into a couple different directions in this talk, because local development can mean many things, right? But if you've seen the AI landscape these days, it's quite overwhelming, right? This was actually, somebody made this in March of 2024. So we're now in October 2025, so you can only imagine how many more projects are out there, right? So it's very overwhelming to even get started with AI. And but what we see is very kind of pervasive here too, is that a lot of these projects are using Python. I'm a Java developer, and yes, I did do some Python, but I'd like this to be a little more simplified for me as, let's say, a more classic application or software developer. So I tried to simplify it a little bit instead of, being like this, where you're the average developer trying to download and run and experiment and manage models and then configure serving runtimes and ensure correct prompt templates, integrate it into your code. I mean, it's too much. So I tried to simplify it just a little bit. So this is my kind of take on a simplified landscape. And I have this kind of left and right of the model. And left of the model is all these mostly Python libraries to train models, to fine-tune models, to do machine learning. And Python makes sense there for the data scientists to kind of iterate and experiment and try new things. And then eventually they'll train some models, and that's kind of what's in the middle, right? Is these models that we can actually use on this right side, which for me, and I don't know if you're a data scientist or an application developer, but for me as an application developer, this right side makes a lot more sense. That's where we actually add value to these models. And then, we like Quarkus and LangChain for J, but I'm not going to go into too much details about that today. But because I want to try this all on my local machine, how do I even get started with that? And why would I do local development? I already said, well, I mean, it's better in the sense that it's free. Is it better in terms of performance? Well, debatable, right? We'll see that in this talk. But it does add a lot of convenience and simplicity if we can just run models on our local machine and try out some stuff. And then maybe when it goes to production, you might use like a larger model or whatever. But for local development, maybe we can use some local models. And then we have more customization, control, and maybe if you're like me and you go quite often on long flights, you can actually use AI on the flight with very limited internet as well. For organizations, it's really interesting too to have models running in their data centers for, especially in this political climate, to have some sovereignty and whatever more, security, cost control, and whatever. But we're not going to focus too much on the organizations. For me, it's more interesting what we can do as developers with local AI. So what open source tech can help us run LLMs locally, and I kind of put the open source in italic because I will touch a little bit on some non-open source stuff too, but for the most part, I try to focus on what's open source so we can also potentially contribute back, and we know what kind of licenses are behind it that are open, and hopefully we can reproduce it. So fortunately or unfortunately, there's a lot of different tools, so you do have to kind of see what makes sense. But let's go through a few tools to at least start running a model on our local machine. So one of these tools is Ollama. If you've done any kind of local development with LLMs, you might have already tried this or used this, and it works quite well, right? It's very similar to using the Docker CLI. You can do Ollama pull to pull a model and Ollama run to run a model, or Ollama serve. So it's quite convenient, and it integrates pretty well with some stacks as well. So, we have simple CLI, it's extensible as well, and it's fairly lightweight. And yeah, for the most part, it works pretty well. So I use this quite often. Another tool that's in the kind of the toolbox is Ramalama. And what's interesting about this one is that you can run AI models in a container. So you don't need to necessarily install anything on your local machine. You can just run it in a container. That has some advantages and some disadvantages, of course, because running stuff in a container potentially maybe doesn't have access to your GPU, but sometimes it does. But it works pretty well. And you can see here that it is actually GPU optimized for most use cases. So that's really great too. But yeah, you need to use a container, and then you can do Ramalama run, Granite, or whatever other model. The third tool, and that kind of builds on top of Ramalama, is Podman AI Lab. So Podman, you may know this if you've worked with containers. It's a way to run containers. And Podman Desktop is a UI tool that allows you to have kind of an easy way to work with containers. And so then it leverages the Ramalama project to run AI models in containers with a nice user interface. So it's maybe kind of cool to show this for a second. So this is Podman Desktop, and you can see here, well, you have containers and images. That's all cool, but you also have this AI Lab extension here, and it gives you a couple interesting things. So it has this recipe catalog where it has a bunch of already kind of built recipes where you can try out some stuff on your local machine to, for example, create a summarizer or a Java-based chatbot with Quarkus, or a graph RAG chat application, or a chatbot using... So you have all these different things. And what's cool is that if you go into these recipes, you can start running this, but you can also access the source code, and you can modify it, and you can play around with it. So I like that. But in terms of serving models, you can see here that there's this catalog. So they provide a bunch of models that you can download from, typically from Hugging Face. Or you can, of course, import your own models as well. But it's all very kind of intuitive to start playing around with models. And then you have these playgrounds and Llama Stack and whatever more. But yeah, that's kind of a cool tool to get started with running AI models in a container. So then the fourth tool, we're going to go through a couple more. LM Studio is, I really like LM Studio because it's very user-friendly, also has a nice user interface, and it has a way to really interactively kind of play around with the settings to optimize the performance of your model on your local machine. The only downside here is that it's not open source. So they have some parts that are open source, but the UI tool itself is not fully open source. So a little frowny face for that. But it works quite well. So I might use this in some demos later on. And then we also have VLLM, which is more for if you're going to run models in your own data center, or if you have a really big kind of a server at home and you want to serve some models that maybe you want to use and share with your friends. So I just kind of wanted to mention it, that this is kind of one of the main ways of for inference servers that organizations are using. So I just wanted to mention here as well. And then I was recently here at Devox. Somebody mentioned that there's also Tornado VM that you can use to run models on your local machine with Java. So how could I not mention that, right? So I tried to get this working for a demo, but unfortunately the Devox Wi-Fi was a little not so good. But yeah, I'm definitely going to try this out, because if it's in Java, that's always a bonus, right? Anyway, so we saw a bunch of different ways that we can now run models, which is great. But what model should you actually be using to run on these model runtimes? So you may have heard of Hugging Face. It's kind of like the GitHub of models. And you can find a lot of models there. So I took this screenshot, I think maybe a couple months ago, and there were like 1.9 million models. Now there's way over 2 million. So we're kind of back here again, right? It's like, what model are we supposed to pick out of all these millions of models? So maybe we can do this little analogy of Mario Kart. Who here remembers Mario Kart? Yes, I was hoping that most people would, because it's an awesome game. But yeah, so imagine in Mario Kart you have all the different players, right? And each have their own strengths, and each one have their own kind of ways to set up the other players and drop some things and whatever more. So you can kind of use that as an analogy for the different models, because they all have their own kind of strengths and their own kind of capabilities. So no, that doesn't necessarily make it easier for you to choose out of those millions of models, but keep in mind that not all models can just be used for any use case. You want to kind of pick and choose and see which model makes sense for this use case and which model makes use for another case. So it kind of, like I said, depends on the use case that you want to tackle, and also how open source it should be, because a lot of models claim that they're open source, but what does open source really mean, right? Does it mean that we can download it for free, or does it mean that we actually can see what data it was trained on, what weights it was trained on with, and whatever more, right? So you need to be a little bit careful with that, especially in terms of licensing as well. And then we have kind of different models. So for example, like DeepSeek or the new GPT-OSS, they're pretty good at like those reasoning tasks where they're thinking. And then you have like Qwen or Granite, they have coding assistance. And then we have Mixtral and Llama. They're particularly strong at summarization and sentiment analysis. But actually, you have a lot of different models to choose from, and they're all pretty good. But kind of circling back to the open source part, you can see like here, this particular model works really well. But to use it, to download it from Hugging Face, you have to actually agree to the license, and then there's, like, oh, well, how can you use it? How are you not allowed to use it? So you need to be, again, a little bit careful. Fortunately, shameless plug at IBM, there's the Granite models, and IBM is actually pretty friendly in that case, because they are training these models with disclosing the sources that they're trained on and the weights. So actually, that's pretty cool. But here's kind of how the naming convention works for these models. So you have first kind of the family name, so it can be Mixtral or IBM Granite or some other provider. Then you have the name of the model and the architecture and version, so Granite 4, for example, or Mixtral 8X. And then you have the number of parameters. So typically, the more parameters it was trained on, the bigger the model. And then what's really kind of important to look at also is this base part. So base models are, as the name kind of implies, they're kind of the base of, so they've trained this model, and then they create this base. And then from that base model, they're going to create specific models. So you have instruct models, you have code models. And so based on that, you can see that an instruct model, for example, is where you give it instructions and it can do something. Code, obviously, is good for code assistance. So you want to look for those kinds of tags as well to see which model actually makes the most sense. Of course, we're running models on our local machine, which means disconnected, so there's no security risk, right? So unfortunately, that's also not the case. There are some malicious players out there that are pushing models to Hugging Face or to other registries, and those models actually have some capabilities to do something not so cool on your local machine. And think, especially if you've seen some of the talks where we're talking about function calling and MCP, you're giving access for these models to take some sort of action, and you can imagine that if you give it some sort of access, that it could potentially do some malicious stuff, especially with code assistants. We tend to be kind of pretty free to say like, oh yeah, this model with this assistant can access files on my machine to modify and create new files. But imagine if it's a model that has not been vetted, that it can do some nasty stuff on your machine. So keep that in mind. Also, that your model comes from a source that you trust. Okay, so what about the model size, right? Because bigger should always be better. The bigger models are trained on more data, so that's great. But of course, on our local machine, that's not so great, right? I was actually at JavaZone last month, and there was a fire alarm just before my talk, and I was wondering if maybe somebody was running one of these big models on their machine. But yeah, I mean, you can think either your machine is going to use way too many resources and is going to start running very hot, or you also need a very, very big machine to run big models. Fortunately, you don't necessarily need like the biggest models out there. A lot of models for local usage are quantized, is basically compressed, and their performance stays relatively okay. Now, I'm not going to say that your Claude and your ChatGPT or whatever are going to work just as well as a model on your local machine. Absolutely not. But there is kind of a little bit of when you quantize the model, that the performance stays relatively okay. But again, those models are quantized. The quantized models that you're using on your local machine are not the big foundation models in the first place. Okay, so hopefully this kind of helps you narrow it down in terms of which models to use. I showed a couple AI engines to actually run your models. So let's get into the more interesting stuff, which is using these models. So the first kind of use case for us as developers is maybe a code assistant, right? So we can integrate models into our code assistant and use a local model with a local code assistant, so we can not use all those tokens that we're a little bit afraid of to use when we're using these Claudes and whatever models. So there's a few code assistants out there, and Stefan came to me just before this talk, and he's like, "You're going to mention Devox Genie, right?" And I'm like, "Oh, I forgot," but I was just in time to add a slide to my deck, and actually that's a really good option for Code Assistant, right? So this actually works with IntelliJ. I believe there's also a plugin for VS Code to have a Code Assistant, and then you can use all the different models that you can see there. I believe it also supports MCP, so we're at Devox, so why not use the Devox Genie? There's a couple more out there. So there's Continue, which is maybe one of the most known code assistants for running on your local machine. And that's one that I've been playing around with the most on my machine as well. And you can see, for example, you can say like, hey, in my code base, and actually the code base tag is deprecated. I should put a new screenshot there. But you can say, create a Quarkus MCP server class based on this REST endpoint, and like based on the model that we're using. In this case, I was, I guess, using Qwen Coder 30B. So that's a fairly big model to run on your local machine. So fortunately, this one is able to handle that. But that's, of course, a consideration that you want to keep in mind as well, as what kind of resources do you have available on your machine, and based on that, you want to maybe limit the size of the model as well. So in this case, I'm able to run a 30B model. It's a little bit slow sometimes, but it's a little bit more performant in terms of capabilities and accuracy. But I often use an 80 billion model as well, and that works relatively okay as well. And again, this does not work as well as using a code assistant that uses a remote model, right? I mean, and you can use Continue with a remote model as well. Continue, open source, just like Devox Genie. So maybe let's go check this out. So I have somewhere. This, by the way, is LM Studio. And LM Studio, like I said, is a way to run models, and you can also interact with the model. So in this case, you can see that I've loaded this GPT OSS 20 billion record, and so you could even chat with it. But we'll revisit LM Studio a little bit later. Here, on the other hand, I have VS Code with continue. I also have IntelliJ, and IntelliJ also supports continue, so you can use it on both. And so you can start chatting with it. And in this case, I'm using Granite 4 model, which was just released. And we can ask a question, and let's see how well that performs, right? So, hi, what can you tell me about my code base? I don't know. I'm not very creative this morning. And so you can see that it's not super fast compared to if you're used to code assistants that use remote models. But let's see what it does. Continue listed files. OK, so it's reading through the files. And then, well, is that all it's going to say? Or, nice. But what does it do? Yeah, so I think we're already getting an idea of, this isn't, sometimes it misses the mark a little bit. You can also try maybe with a different model, but what about the file that is open right now? Okay, and then it wants to read the file, so it has access to tools, which is a good thing. Continue didn't used to be able to write to the files themselves, and you would have to like copy and paste. Now it's able to do that as well, which is great. So now it's at least able to get a little bit more interesting information. So this happens to be our Quarkus LangChain4j agentic lab that we did here earlier this week, and you can also check that out. I'll share the link later on. But anyway, so that was a real quick kind of example of using a local model that's running on my local machine. Oh, and maybe one thing that I wanted to also mention here is that it has, in the configuration, you can define what kind of models it has access to. So you can see here, I have Olama and auto detect. So all the models that are available in my local Olama can be used. And then you can also use, for example, you can provide URL to other models. So for example, what's running in LM Studio or with Tornado VM or something. All right, so let's go back to our slide deck, which has disappeared. Where is it? Wow. Let's go to the browser. Oh, that was the slide deck. I was like, oh, that's just a code editor. All right, so another tool that's interesting is Cline. Cline also integrates with VS Code. There's also Roo code. So you have different options. I recommend trying them out and seeing which one works best for you. What I found is that sometimes continue add some updates, and then that one actually has a leg up on Cline, and then Cline updates something, and then Cline is a little bit better, and then maybe Devox Genie adds some new features. So maybe play around with it and see which one works for you today, and which model works better today. And then you may have used Cursor. Cursor is also a very popular code assistant. So this one actually does not really support local LLMs, or at least not out of the box. You can kind of mess around with it a little bit and then use a local LLM. But you can see, took this screenshot because you can see that there's a lot of people that are looking for local ways to use local models, right? Because using these remote models that's really performant works really well, but it's also kind of expensive sometimes. And we need to create accounts there, or all these tokens. And so it would be nice if we could pick and choose when to use a performant model if we needed to, or use a local model if we just need to do a couple small changes. And if we can switch between the two, I think that's the best world. And so sadly, Cursor, I guess, does not support that yet, but maybe they're watching this video and then they can maybe push this a little bit harder. But there are many tools, like I said, continue that do that. All right, great. So Code Assistant, we have some options now, right? So we have some tools, we have models that we can use with that. So there, again, are some models that are specifically trained for coding. So in my case, I was using just Granite 4 as the general model, and maybe I should have used the specific coding model, and it would have been a little bit better at understanding the code instead of, a general purpose model. So now what about Java, right? Because or at least I am a Java developer. How can I use all these kinds of tools to now integrate into my Java application using local models, and then also using some stuff to do my local development with AI? So you've most likely heard of MCP these days. It's a way to integrate tools with LLMs, and then you can use those tools remotely. So we can create MCP servers, MCP clients, and we can do that all on our local machine. So we don't need to, in this case, it says remote services, but we can create all of this on our local machine using local models. So let's try that for a little bit. So I'm going to go to my project here in IntelliJ. I want to make sure everybody gets some exposure. So VS Code, IntelliJ, they're all happy, hopefully. So here we have a project, and this is an MCP server, and this MCP server is a wrapper around a REST client that goes to my weather station at home, because a lot of times, I don't know if you've seen any demos, a lot of demos were about an MCP server that gets the weather forecast or something from Open Meteo or whatever. So I wanted to do something a little bit different, so I'm also going to get the weather, but from my house in Switzerland. So you can see here that we're using Quarkus here, so I created a Quarkus MCP server. And there's not much to it, really. There's just the pom.xml that has the MCP server extension here. And then I create this MCP tools, and one to get the current weather, one to get the available devices that I have at home, and then also one to get the historical weather, so I can ask it, what was the weather or what was the temperature like yesterday or something. So what's interesting here is that you have the tool annotation and then these tool arguments that describe different arguments that the LLM could potentially use. Now, that's not necessarily the point of my talk, but I just wanted to kind of point that out. So now if I start this on my local machine, of course, it's going to start up. And then it's exposing the MCP on localhost 8081. And so now I can go, for example, because this is just an MCP server, so any kind of tool out there that supports MCP can use this. So LM Studio was the one that I had open just a little bit ago. And in LM Studio, you can actually also provide MCP servers. So let's restart this one. OK, let's edit it, see which port it's looking for. Port 8080, let's call it port 8081. And this dev MCP is going to be something really interesting as well. Okay, so not C, but SSE, I believe. So let's restart it, C. Oh, maybe it's just without the SSE, I forgot. What do I need to? Oh, save it, you're right. I'm so used to IDEs just like saving my files for me that it's okay. So now you can see that it recognized that there's an MCP server running on localhost 8081, and we can see the different endpoints for this MCP server. Now I can use this to kind of just start chatting with my local weather station, all on my local machine. Well, almost all on my local machine, because of course the API call to my weather station is not here in the room, so that's the only kind of cheat that I'm using. So that's the only internet that I'm using here. All right, so let's see. We're going to start a new window here somewhere. Where is it? There we go. Need to maybe close this. Here we go. OK, and then you can specify, I want to use MCP local MCP, and then ask it, what is the current outdoor temperature at home? So it's kind of local development because it's at my house, right? Does that count? So we can see that it's using OpenAI GPT OSS on this machine, and it thought for a brief moment. That's cool, and it gets the current weather, and it says it's 12.5 degrees Celsius at home. That's great, great. What was the highest temperature outdoors yesterday? And now it's going to be interesting because it starts to become a little more tricky with these local models. Sometimes they can do it, sometimes they can't. It does understand that it needs to call the historical weather, and then I don't know, for some reason it gets the available device, it's going into a crazy loop, but in the end it says, I pulled the latest 24-hour readings for your station, the home in the Swiss Alps unit. The maximum outdoor temperature recorded on October 9th, yeah, that's correct, was 13 degrees. Not very warm, but yeah, okay. So it was able to do it this time. So that's great. And so imagine that if you're playing around with AI and you want to, do some stuff and maybe create some MCP servers, maybe you can tie it into your home system, and now you have a chat interface all running locally to start, kind of doing some really fun stuff and to annoy the other people in your house. Maybe you have access to your lights at home and you're like, hey, set the lights to a different color and do it at this time, so schedule it and blah, blah, blah. So you can imagine there's really fun stuff to do. And again, all local. So that's great. Now we have an MCP server running on my local machine. And I wanted to also point out that if we go back to the configuration, I have to remember where that was. I was just there. So I'm not like, okay, edit MCP. And here it also reminds us that MCPs are useful, but they can be dangerous, of course, because if you just plug it into anything, you're going to not have such a good time. All right, so now I'm going to do MCP. I think it's localhost 8081 q dev MCP. So this is a very new feature in Quarkus that exposes the Quarkus dev mode as an MCP server. So let's go to the LM Studio and then do a little chat now with the new, I need to save it probably. Did I not save it again? Oh, yeah, you're right. Okay, well, we can forget about the previous one and just use this one now. So q/dev MCP. Okay, and then it's not so happy because I probably need to restart it. Oh, and maybe it's not the right URL. Okay, let's go back here. Let's go to the Quarkus dev mode, and then I can see it. So here, if you're familiar with Quarkus, you may know that this is, if you start Quarkus on your local machine, you have this dev UI interface, and it shows you all these capabilities that your application has. So for example, it has this tools, because I have an MCP server running, right? So you can see all the different tools that are exposed. We can even try them out here. And then call it, and then it also says, oh, your indoor temperature is 22 degrees, the humidity, blah, blah, blah. But anyway, so this is also really cool because you can test some stuff out. But here on the right side, there's this new experimental thing, dev MCP, and this is probably why it wasn't working, because I need to enable it first. So now it's running on localhost 8081 q/dev MCP, and you can see all these different tools that are exposed during the Quarkus dev mode when you're running this in with MCP, and so you can see not all of them are enabled by default. But let's see, I want to maybe just get all endpoints. So we can again go to this little tool here, the LM Studio, or this can be any kind of client, right? But let's try it out real quick. Need to restart it one more time, and you can see now it has access to all these tools from the dev mode. And if I enable it here, what endpoints are exposed in my application. So it's calling get all endpoints, and yeah, there they are. So there are the endpoints that are currently running in my Quarkus application, and it says, oh, you also have these health endpoints and whatever available. Now, I'm using this in an LM Studio, so I'm just chatting with it, but imagine if you're using this, you can also use it in your code editor. So we were using this in IntelliJ, and we also have continue running there as well. So we can also start chatting with continue here. It says nothing to show. That's really cool. But I guess I can use continue in VS Code, even though it's a different application that's running there. And also, like as you're interacting with your code, you're generating some code, but you can also get feedback back from the application itself. So what endpoint, well, that's the same question, but what is the Quarkus MCP server exposing? Oh, there's an issue fetching the list of endpoints, blah, blah, blah. Probably is not entirely configured correctly, but we can work on that. So now I have this MCP server, but I also maybe want to use it in my local application. So I'm going to stop this one. Command C, Control C, whatever it is on Mac. And then let's try this one. So this also is an application that uses the whole agentic system that Mario worked on. And let's see what we can get out of that one, because that also exposes an MCP server. And if we enable that, we are running on port 8080. And we're going to see that there are some more tools available, because this one uses a database. And let's go to VS Code here and try it again with using the tool. I think that's okay. Okay, so what database tables are available in my application? Wish me luck here. But you can see here that it is trying to do something, and I think continue will use the Quarkus MCP get tables tool, so that's already a good sign. But no, it's not happy. So let's try a different model. Let's try this one. Try again, and that's kind of the fun part with local models, is that you can just switch models and then see if another one works better. So this one's a bigger model, so it's going to be a little bit slower, but let's see what happens. And in the meantime, you can see that I have the Quarkus MCP server configured here in VS Code. And that's probably why the other one wasn't working, because it was on port 8081. All right, so it's thinking, and now it seems to be getting into a loop. OK. I don't have direct access to your database, even though it was previously trying to call the tool. But anyway, you can see that it sort of works, and it sort of doesn't work. And that's the fun part about running these things on your local machine. So you have to try to figure out a little bit more than when you're using a paid system, how to kind of mess around with it. And that's kind of hard to do when you're live on stage. All right, so we saw, and this is also kind of interesting. So with MCP, you know how Anthropic is like, oh yeah, and you can use MCP clients like this client.py. We can just use Java MCP clients too, right? So, and that's something that we could do as well, is just start a client on our local machine, an MCP server on our local machine, and we can also chat with it in that way. And then here you can see that we have the Quarkus MCP server as well. So let's try one more experiment since we have a little bit more time. So I'm going to stop this application right here. And then let's go and open another project. File, open folder, and then homebot. This sounds really fancy, but it's just a client for using the MCP server that we started previously here. So I'm going to start that back up, Quarkus dev, and then let that start. And then here we're going to start the home bot. And we're going to also do that. Where's my terminal? Up here. Quarkus dev. And so this client is going to call the MCP server, also running on my local machine, using a local model. And then we can see that it's running on localhost 8080. And then if we go to that, we have a fantastic Quarkus chatbot with a really cool interface. And now we can try also, can you get my outdoor temperature at home? And it should answer, hopefully, with my local temperature, calling from the one client running on my machine to the server running on my machine. And it says, oh, the temperature is up to 13 degrees outside. But again, in the Quarkus dev mode here, we can see there's localhost 8080 that has some interesting things as well. So I showed you the MCP server that had tools available. And here we can see that we have the client also running with the extensions. And then we see that there's an MCP server, but it should also, here we go, the MCP clients. So we also have available to the tools that are exposed by an MCP server directly into this Quarkus dev mode. And again, we can try this out to get the weather straight from this Quarkus dev mode, and it's a little bit grayed out, but we can see here that the temperature, the outdoor temperature here is also 13 degrees. So we can do our local development, we can debug, we can access our resources that are running in this application, and this is, I don't know if I've really shown how this MCP server, what kind of interesting capabilities that has, because when you run Quarkus dev in dev mode, it has self-awareness of what is running in my runtime, what kind of metrics are available. So you can imagine by exposing that as an MCP server in our code assistance, now we don't just have access to the files that are in the context of the IDE, but we also have access of the entire runtime of the application as we're developing. So we're going to get a lot of feedback loops. And then if we can use local models, we get some pretty cool stuff to work on our local machine. So just kind of wrapping it up here. So there are many options for serving and using models locally. So I hope I didn't overwhelm you. I tried to show you some things that you can do, where you can find them, what you should look for in terms of models. Pick the right model for the right use case. As you saw in my little experimentation, some models were answering correctly, some of them were not, some are slow, some are faster. So you kind of have to find the balance there, right? Make sure that your model comes from a reputable source. Don't just start playing around with any kind of model. Make sure that it doesn't have anything malicious in it. Well, I showed that local code assistants work-ish, right? You can get it to work pretty well if you massage it well and you play around with it and you provide enough context, as is the case with working with models in general. But yeah, you might need to ask for hardware upgrades for running, especially if you want to try with some of these bigger models. But smaller models, and there's also like the smaller models like the Qwen 1.5B that is fairly small, that you can run on your local machine just on CPU, so you don't necessarily need GPU. It's not going to work as well as bigger models, but it works fairly well to at least try experimenting with it. Some models support tool calls, some do not, so that's another thing that you want to keep in mind. And then, well, hopefully I showed you that developing local agentic AI apps with Java is also definitely possible. We've had many sessions about that this week, but hopefully I showed you a couple more little tips and tricks about doing that on your local machine. And well, it's kind of fun with Quarkus, but maybe I'm a little bit biased. And that's about it. So if my slide wants to go to the next page, then, oh, there we go. Then you have access to the slides, so you can revisit all this stuff that I talked about today. There's a bunch of links. There's more projects out there. I didn't list them all here. But yeah, let me know what you think. Connect with me if you'd like, and give me some feedback on what works for you. And if you thought this session was useful, then of course, let me know as well. Thank you.